All right, I wanted to show you guys what I've worked on so far for the clock. So I'm building this. I'm putting this onto a PCB. Here's the PCB. Well, this is just an example of what it'll look like. So it's going to be nice and solid and be able to, hold the clock. And if I drop it, it'll be able to uh, still work instead of having wires everywhere and risking the possibility of having wires being pulled out. So I'm using software. This is EasyEDA software. This is just an online software that I'm using, and you can also build the circuit uh, in the schematic view, like I'm showing you right now, and then I can order the boards. And this is kind of like the PCB view. So let me show you through the what I've got so far. So this is the display driver. So what this board is, it's just so my clock is going to have two boards. It's going to have a display board, so it'll have like a display board here and then the logic board, and they're going to meet together using some connectors. And so I just did that design just so that it would be more compact and cleaner, I guess. I just wanted to, and it kind of simplifies the circuit too, because you can see here on this board, I've got the um, six 7-segment displays, one for the seconds, minutes, and hours. And then I've got the driver ICs, and then I have the pins, the 4-bit data pins going into each driver to drive the segments. And that's basically what this board is. I also have some LEDs for the colons. You know how sometimes a clock will have, like a digital clock sometimes has a flashing colon in between the hours and the minutes and the seconds. Um, and then I also have the AM PM indicator LED right here, as well as minute and hour set. So I can set the minutes and hours on this board. I also have the dimmer, two dimmers, two dimmer potentiometers. One dimmer potentiometer is dimming the 7-segment displays, and then the other dimmer will be dimming the colon and the LED, the AM and PM indicator. And I just did that because I just was thinking, well, the 7-segment displays are going to be using a different amount of power, I guess, and the LEDs might be using a different amount of power. So I was thinking if I had them on both, on just one potentiometer, the brightness might not match. So I just split them up into two. So it's not very, I guess, cost effective, but it's just a prototype, and I'm just doing it for fun. So this is the display board. So this is the top board, and then it's gonna connect onto the logic board. The logic board handles all of the, I guess, computations, I guess, of telling the display board what time it is. So the logic is here. It was really confusing to be able to do it all. I really had to be careful, and I still need to go back and check some wires. But you can see here, these 6 chips up here are sending the 4-bit data to each segment. So I've got seconds, minutes, and then the hours. And so these chips are the 74192 up and down binary counters. So I have them just in the counting up mode, and they're all each feeding the display drivers. Some of the logic for so as in my previous video, some of the logic to increment the minutes and the hours is a little bit complicated, but I can kind of just show you guys what it's doing. So obviously the first second spot is getting the clock. And the clock in is on pin, let's see, pin 5. So this wire right here is up. And that is going to clock. Let's see, actually, no, that's not it. Up, down, increment. No, that should be it. I think I just have it going into a... Oh, sorry, I'm following the wrong wire down here. You can see, yeah, super confusing. Like I don't have it really laid out too well. Not in like, I kind of have it in a logical way, but okay, so pin 5 is the clock pin. So every second, I'll have a second pulsing circuit that's gonna increment the seconds. So when this reaches 10, or when this reaches 9, and then it goes back to 0, it's gonna carry out a bit right here. CO number 12 carry out goes into the next segment, and this one it'll increment this this chip. Once this chip reaches 6, it will reset and increment this chip. And I have the reset right here. These two purple lines are coming off of QB and QC, which is binary 6, and those lines are going into a AND gate, and then the output of the AND gate is going into the clear of that chip, as well as the load of the next chip. But because I have a set button where you push the button so you can increment the minutes, I have to go through an OR gate, and so the signal goes through an OR gate as well as the push button signal, and then that output's gonna go up into the up and down, or into the up, so it'll increment the minutes. That just makes it possible so that I can set the time without having to stop the clock or do anything fancy. I can just one push of the button, I can increment the minutes up and down. Sorry, I can only increment the minutes up. I can't increment the minutes down. And then once this chip reaches 9 and goes to 0, it's gonna push out a carry bit and carry out into the minutes again, and then we're just gonna repeat the same thing. The binary 6 goes into an AND gate over here, and then the output of that AND gate goes into the up of the, sorry, actually it will actually go into the, it'll go into the OR gate again, so that I can increment the minutes. Sorry, I'm just trying to think. I think I do have something wrong here. Let me just do a quick, you can even, as you watch it, I can kind of go through how I debug this. So if I can increment, if this one is going, so if I've got, this one's going up, this one's going up, and that has 2 signals coming from up. Oh, yeah, that's right. Okay, yeah, that's right. I was just checking. So when I push to set the minutes, I am setting the first spot of the minutes, not the tens of minutes, but the ones of minutes. And then when I set the hours, I'm setting the ones of hours, not the tens of hours. So I'm setting this chip and not this one. So I was just checking some of the wiring there. Anyway, so once this reaches, this is where it gets confusing. I can increment this. This one's gonna go from 0. Actually, sorry, it's gonna start at 1. It's gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9. Carry out a 1, so it'll be 10 o'clock. 1, 0 is 10. 1, 1, 11. 1, 2 is 12. when it goes from 2 back to, it's going to go from 2 to back to 1. So it's going to go, so the carry out, it's going to have, when it's binary 3, it's going to go into binary 3 is going to go into a AND gate. The output of the AND gate, binary 3, so I got this one. Binary 3, and when this one is a 1. So when this is a binary 3 and when this one's a 1, it is going to send out a signal, a reset signal, to clear this and to load back a 1 into this spot. I'm so sorry, this is so confusing, but I don't know how I can make this any easier. I'll try my best, but this is just an overview of this. So anyway, there we go. So I can increment the 12, the hours, and I've got the logic down here. I also have some debouncing circuits down here, RC resistors and capacitors to debounce every button push, because a button push isn't exactly one button if it's not debounced. Down here I've got a clock pulse. This is where I will be creating the clock signal. And then this one is just the main ground 5-volt clock, AM, PM indicator. And so this is going to be on each board, connecting all the board's grounds together and all the board's powers together. So let me show you the PCB. So this is the PCB for the display board. Let me change the background so it's easier to see. Let's see. Actually, I think black might be the best. As you can see, it's just I've got the board here, so you can see that there I got 6 of the displays, the LEDs. Here are the potentiometers, and here are all of the data lines, I guess you could say. Here's the hours and the minutes set, and then I got the IC chips here. So this is the top board, and then this top board is going to connect to this bottom board that I'm working on. This is the logic board. You can see that I still haven't completed it. Still working on it, but I've got to route each one of these, each signal I have to route, and so it's taking me some time to do that. Anyway, that is my 12-hour clock logic update. I hope I can make a video that will make more sense about how the hours work, because I know that is the most confusing part of this clock. And I know that many of you have school projects that, this is your school project, and it's hard to work out the logic if you don't know how to do it. So I hope I can make a video that will go over that. Anyway, thanks for watching, and we'll see you next time. Bye.